So I wanted to try something, a little experiment, uh, something a little different. I am trying to work on a history of science project, which for various reasons I need to do some work on slightly urgently, even though it's about something that happened 100 years ago. And I thought I would try and do a little bit of that work kind of live on Twitch and in public. So the topic is the chap shown on the screen here, a certain D'arcy Wentworth Thompson, the guy holding the bird skeleton. He was a scholar, let's say, in Scotland, who wrote a book in 1917 called On Growth and Form. I have a page up of that book over here. On Growth and Form was an attempt to use methods from physics and mathematics, particularly mathematics, to try to understand biological growth and form. And he had all kinds of wild things, like there's another skeleton, and I think if we try different pages, we'll find all kinds of curious things. I think maybe I'm about to hit some of his most famous pages here. Oh yeah, here we go. This is his theory of transformations of form, and so he's talking about how, let's see if it comes up, yes, how different creatures are related by various kinds of mathematical transformations in their shapes. Yeah, this is a very famous picture. That fish is kind of like that fish if you stretch it out a lot. It's a little weird, and in the end it's probably wrong, but anyway, I thought since it's the centenary of D'arcy Thompson's book that I would try and write some things about it. There's an archive of D'arcy Thompson's papers in St Andrews, Scotland, and a young person's been kind enough to go visit the archive for me and go make a bunch of photographs. And she's not going to be in St Andrews much longer, so I have to kind of get back and say which more photographs I want. And that brings me to what I have to do this evening, which is to look through a large number of photographs and try to figure out which ones are there or are not there. Why do I care about this stuff? Well, needless to say, in my big book, I studied a bunch of things about, see, I have a section called Growth of Plants and Animals, which is about things like how plants can grow and so on. And let me just see. So I had let's see. Yeah, there's an antler or a horn or something, and I found all kinds of interesting things, but they sort of followed on in some ways from what D'arcy Thompson had done in his book in 1917. So okay, let's get to work. What I wanted to do here was to go through a bunch of these documents. I think I have here, let's go look. I have a whole directory of these things. Yeah, okay, there's the first 5 of them. Let's just see how many files I have. I have 1,168 pictures. Okay, well let's start looking at them. So here they are in a picture viewer, and I think let's see. Okay. This one is from 1924. So D'arcy Thompson lived from 1860 to 1948. So a bunch of the letters and documents that we have here should be from the kind of late Victorian era. He was a bit of a Victorian gentleman kind of guy. Okay, this is from 1924. French is conveniently one of the few languages other than English that I can actually read. Okay, this is from D'arcy Thompson writing in French. He says he's he's occupied with the revision of his book. That was in 1924. He actually didn't get the revision done until 1942, so it took a while longer, but I don't think this letter isn't that exciting. Okay, I did notice this one earlier. This one is really fun. This is from 1925, and the author is presumably the Giuseppe Peano, who was the creator of Peano's axioms for arithmetic, the things that Kurt Gödel showed ultimately led to undecidability and so on. Now, unfortunately, I can't read what is presumably Italian, but it's clearly something about the solids of Archimedes. It's rather charmingly, it says Scotland, Angleterre. Scotland was not then, and perhaps decreasingly today, wants to be considered part of England. Alright, let's take a look at what some of these others are. Oops, this looks to be okay, article on the Bee of Artemis. Now, I've looked through some of these early ones, so maybe I should go and go a little bit later here. Let's go scroll down here, because I've looked at some of the early ones here. There's some really curious things. All sorts of strange pictures. This one was a picture that claimed to be... Oh, what the heck is that? That looks like a telephone cord. And I think this had a... I am sending and enclosing a photo of the wool. I do as you say. There's a whole skin of ordinary wool, but Woolworth's rug wool is better because you only need one thread. The other photo shows a chromatid of a daughter chromosome with major and minor spirals at meiosis. I don't think that's a real picture of a chromosome. I think that must be somebody's model of what it might have looked like. Well, it's rather curious. One of the things this chap was very keen on was understanding the shapes, that if you put a bunch of bubbles, if you squash a bunch of bubbles together, what shapes they make. He was interested in that because he wanted to understand the shapes of biological cells. And Kelvin had discussed how those things form tetrachydecahedra, which means tetrachydeka is Greek for 14. So these are 14-faced hedra. And Plateau, who was a big soap bubble person, let's see, what is this? Will be okay. So within a tetrahedral cage, so may a cubical bubble be introduced into a cubical cage. Yeah. Well, let's take a look here. I think I'm going to go on and look down a little bit further here, because I've looked through some of the early stuff. I think that's a picture of the current state of D'arcy Thompson's house, with a plaque. D'arcy Thompson lived here. Okay, let's keep going, because I want to get to the stuff I haven't looked at all before. There's a very curious make-it-yourself polyhedron here. Let's keep scrolling. And okay, I think I have not looked at this, so let me get started right here. So, what is that polyhedron? My gosh. Well, it's mostly hexagons, and anything that's mostly hexagons is going to be flat. So I wonder how the thing folds up. It must be, I'm thinking it folds up. Oh, I see. Maybe, maybe not. Oh, I see what happens. So this thing here kind of overlaps another one to make something that's more like a soccer ball, and has pentagonal faces as well as hexagonal faces. Alright, let's take a look at what he's talking about here. I'm guessing that's his signature down there. And what on earth is this? So far that is seems fairly plain sailing. But then I, of course, am up against a snag. For P3 plus P5 prime ought to be possible because of whatever. Oh, so he's trying to work out, I think, what kinds of forms. Yeah, 10 hexagons, 3 pentagons, 10 hexagons. So basically he's trying to discover the buckyball here. Okay, I don't actually know how much. Let's take a look whether a buckyball, what the actual story of a buckyball is. I wonder whether we have I wonder whether we actually have that as a polyhedron type. Let's see. Oh, we have it as a chemical. Let's see whether we have it as a polyhedron. Yes, we have it as a polyhedron. Good stuff. A truncated icosahedron. Okay. So let's see what happens if we say we want an image of that. Okay, there it is. So actually what I want to do is I want to look at the so that's the thing, and there it is, rotating around. So let's see whether his creature here is plausibly like the buckyball. Let's take a look at this here. So let's see, how many hexagons are there in this picture? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plus 6, 16. Plus another 7 is 23. Plus another 5, 6 is I just lost count. That's what I get for looking at the okay. Silly me. Okay, where have we got to? I'm going to do this again. 3 plus, this is where I fail on arithmetic, that adds up to 9, plus plus another 6 is 15, plus another 7 is 22, plus another 6 is 28, 29, 30, 31. So let me see. So now we have somewhere here. Let's go back there. So that was, so he seemed to have 31 hexagons, and then he had a bunch of spaces there. So he had 1, 2, 3, 4, 5, 6, 7, maybe 8, 7 or 8 spaces. So let's see, 7 or 8 gaps. So let's find out whether our truncated icosahedron, what its how many faces of different kinds it has. Actually, you know what? I'm just going to go ask Wolfram now for that question, because I think it's faster than going and figuring it out this way. So let's go. This was a truncated icosahedron. Okay. Oh, 32 faces it claims. So maybe I was just off by 1 when I did that count. But it's 32 faces, 12 pentagons, and 20 hexagons. So I don't think old D'arcy Thompson had it quite right there. Okay, well that's sort of interesting. Alright, let's keep going. So maybe that's why he couldn't figure out what was going on. Let's take a look at what some of these others are. What on earth is that? That is some kind of picture of a projection of this. And what is this? That is, you know, it's always interesting to see people's arithmetic. 2 point, okay, I have to work out. So he says that's 4.99999. Come on, let's see. Okay, when in doubt, try to OCR it. Let's see whether we can do that. Let's go over here. Let's say text recognize of that. I don't think this is going to work. Oh yes, it worked. Great. Wow. There's the number. Okay, so let's take that number and square it. Whoops, well that was just a string, so let me just make that into an actual expression. So let's just pick that out and make it into an expression there. Let's just say to expression, and then let's say that squared. Oh, it says it's really close to 5. Okay, well I see. So this is, so let's say number form of that, comma 10. So it's 4 point, lots of 9, 6, 6. So let's see what old D'arcy had for that. Okay. Wow. Okay, I wonder how he worked that out. I wonder if he had a desk calculator. I bet he had a desk calculator. I can't imagine him actually working that out by hand. See, that was on line 29. Let's go to like 15 digits and see whether it agrees. There it is. Okay, let's see what it said here. Yeah, that's curious actually. Where was it? It was over here. No, that's a different one. There we go. Puh. Strange. Okay, well, I don't know, either that's him doing, maybe, you know what, I'm being silly, because that's long multiplication right there. There it is, okay. Alright, let's keep going here. Let us see what's going on. Why was he doing that, working out that square of that number by hand? I have no idea. Let's see what he was doing here. This is, what on earth is this? This is, oh, that looks like it is rational approximations to square root of 3. What a strange thing to work out. Square root of 5, rather. Okay. Well, actually, we could probably do the same thing. Let's see what he gets versus what we get. Let's see. We can just clip that out and see what we get here. So let's say we say rationalize square root of 5, comma 3, for example. Okay, let's make a table of a bunch of these things. So let's say table there, n up to let's say 20. Oh, that was silly. What do I want to do here? The second, I think maybe what I'm doing, I want to say 10 to the minus n there. Okay, there we go. So there are some approximations. Let's compare those with his. So he had 4 over 9. Then we have 29 over 13. Oh, he has 17 over 38. That's what we also have. 161 over 72. For some reason he missed out the 29 over 13. Okay, so 682 over 385. Let's see whether he has the 219602. So those are continued fraction. I think those are the continued fraction approximations to square root of 5. Now, why he's working that out, I know why he's working that out. He's working that out because he wants to know whether this funny polyhedron that he has, what he has to deform in order to get it to be, because you can't make a polyhedron, a regular polyhedron. He's trying to work out something about the deformation to get something which is as regular as possible. Okay, what is this? That looks like pictures of various kinds of alkane molecules, I would guess. Why he cares about that, I have no idea. It's okay, what is all this? Possible regular polyhedra. Theory of polyhedra. Okay, so he's working out what is, okay, so this is fairly standard stuff. Okay, this is from 1932. This is fairly standard stuff in probably Euler's theorem in the structure of polyhedra. Let's keep going here. See what he's got. Double tetrahedron, I don't quite know what that is. Okay, so he's making various analogies with structures that you can make from carbon atoms. So, and he's, I guess, not discovering Buckminster fullerene. What is all of this? Let's see, hard to read this stuff. All want to know the 5 regular solids, the tetrahedron, blah blah blah, something about Pythagoras. Can't read it. Go on. Okay. I don't know what to do with this. Let's see what happens further on. Okay, sides of a pentagon, so he's working out what happens there. It's let's see. Oh, I see the chat. Somebody is asking me about complexity science and AI and so on. This is not the moment when I'm going to be able to say something about that. I'm trying to. I'm back 100 years from that. This is a chap who, D'arcy Thompson is a chap who might have gotten into that stuff had he lived another 50 years. I think it's D'arcy Thompson was interesting because he had a background in classics. He studied Aristotle was his big role model, and Aristotle wrote some fairly silly things about natural history, and I'm afraid D'arcy Thompson somewhat followed them. Okay, so here are various kinds of computations he's doing. Why is he doing this? Hard to know. Okay, so this is various pieces of geometry. My dear Thompson, your method of constructing 1921. Your methods of constructing the model is very neat. Of course, you can close it completely by cutting out your windows on 5 sides and leaving only the 6th as a hinge and modeling the shape of the flap as a square or a regular pentagon. Blah, 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 blah. I don't think that Kelvin would have claimed this ordinary tetrachydecahedron. I think he would have said it was a generalized tetrachydecahedron. Okay. Okay. Actually impossible to cover a sphere with a network of hexagonal meshes all similar and equal, you don't say. The mathematical conclusion is something inescapable, unescapable. But you can cover an octahedron with a network of equal hexagonal meshes, not too surprisingly. Therefore, you can close any closed surface with a network of unequal hexagonal meshes. Yes, indeed. That's how computer graphics works today, in a sense, except they're triangular meshes which are dual to those. Okay, not too exciting here. What's happening now? What is that thing there? Oops. There's a general 3-something set of atoms covering a general surface. Problem: follow the mesh outline. So I guess these people are doing early versions of who was that, by the way? W. Pedlin. I don't know who that is. Seems to be the same chap here, writing again 1921. Great. We've got a little construction kit here, and more of a construction kit, and this seems to be a paper on the 13 semi-regular solids of Archimedes. Okay, so that's probably what he was exchanging mail with Peano about soon thereafter. So these are the so-called Archimedean solids. I think we actually have a nice let's see, Archimedean solids. Let's see whether we know about these. Yeah, okay. Let's take a look. What's the entity list of those guys? There they are. Let's see if they're really 13, as D'arcy Thompson claims. Yes, there are indeed 13. Okay, so let's see what he ends up saying about them. Where was that TypeScript? I think, oh, I see, it's off the screen here. There we go. The semi-regular solids are contained by similar and semi-regular symmetrical bodies by dissimilar polygons. Yes, indeed. Okay, and here is, oh, that's kind of cute. We can compare. Oops, there we go. Let us see whether the table he has there is well, I think he's using. There we go. That's his table. The cubum simum we call the cuboctahedron. The okay, so the cubum truncum is probably the snub cube. Yeah, but I guess he's using the original Latin names. It's cute. Okay. Let's see here. What do we have next? Okay. Well, looks like this is a section on lots of things about polyhedra. So let's keep going a bit. More polyhedra here. Let's see what's happening in these letters. I am sorry that the paper, The 13 Semi-Regular Solids of Archimedes, has been held up so long at the Royal Society. Oh dear. That's one of those things journals. Okay, first referee oh my gosh. Okay. This is a referee report. That's interesting. So in those days, as I haven't published an academic paper in years, but those things have a terrible habit of having they're very it's a bit of a corrupt system usually. But let's see what this person had to say. Okay. Both to referees to whom it has been sent explained it has been necessary to keep it for a long time to come to a conclusion. Report of the one referee. Another referee points out that not more than a third of the paper can be described as in any sense new. So typically the statement is it's not new and it's wrong, or it's both. But states that the main substance were new, he thinks it ought to be printed. Okay. As only a small part of the paper he knew, he considers that the Royal Society would be justified in refusing to print more than the first referee has suggested in the paragraph I have marked in pencil in the report. Okay, that's interesting. So it's like, we'll publish part of your paper. Okay, let's keep going, see what they say next. So condense it, blah, 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 blah. Oh, that's genes. He must have been the president of the Royal Society. That's the genes of the genes limit in astronomy. The limit for when a self-gravitating system will be stable and so on. Okay, let's see what these guys had to say. The author gives a detailed account. I can't imitate anymore the how this would have been read in traditional British form. Let's see. I think okay, blah 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 blah. There is no rivalry, as the author would suggest, between his empirical and mechanical production of the polyhedra and their geometrical derivation. Okay. On the whole, I'm inclined to think that a brief note on this mechanical production of polyhedra might be thought interesting and worthy of record. The kernel, interesting, they spelled it either wrong or in an early spelling with a kernel, Kernal. Maybe that's a different form of kernel. Maybe it's a British form. Okay, now he's going to condense his paper in 1924. Okay, so then probably something happened with that. Okay, let's see. Regular polyhedra, blah 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 blah. Okay, that's a nice color picture, which I'm sure they didn't print in the journal. All right, let's keep going here. Let's see whether we can get out of the polyhedron section. Seems to be a lot of polyhedra there. What on earth is that thing there? That? I don't know what that is. I don't know what that is. I have no idea what that is. Okay. Let's see whether there's anything around it that would give a hint. Let's see what the next document is. The whole series of regular and semi-regular polyhedra. Okay, so this is more in the polyhedron story. Okay, there's more polyhedra here. What is this? No, actually, I think this is going to give us a clue about what that is. That appears to be some kind of numbering scheme for polyhedra. Oh, I see. So this is DWT is his initials, D'arcy Wentworth Thompson. And I don't know what he's doing here. No idea. Alright, let's keep going a bit. So, this is more on polyhedra. I want to get out of the polyhedra section. I think I understand what he's talking about with polyhedra. What's this? Yet more. See, he's trying to use polyhedra as models for the shapes of biological cells when they're all smooshed together. But let's keep going here, see whether we can get out of polyhedra. What's this? Square Roots and Others by C.V. Boys. If I remember correctly, Boys was a guy who did a lot of soap bubble stuff. Why does he have a thing on square roots? Oh, that was what he was doing earlier, the nearest fraction to a square root. And various convergence of square roots. That's continued fractions. I think. Okay, so I don't think we need this anymore. We can compute square roots at lightning speed these days. These wonderful tricks for computing square roots are not really important anymore. I mean, we use them inside our language, but okay. Stuff about theory of numbers. Okay. Oh, that's interesting. That's cute. That's arranging numbers in rectangles. So if the number is composite, you can arrange that number of dots in a rectangle. If the number is prime, then you can't. I've always liked that fact, but it doesn't seem to be very well discussed. Okay, now he points out that you can have triangular numbers. We know that. Okay, now it looks like he's discovering differences of triangular numbers, which needless to say, because triangular numbers have a formula n times n plus 1 over 2 or something, they have second order differences that are constant. Okay, this isn't very exciting. This is discovering figure-8 numbers of various kinds. Okay, this is looking at square roots. I don't care particularly. What on earth is this? Excess and defect, or the little more and the little less. From what year? From Mind, which is a philosophy journal. Wow. Okay, that's wild stuff. Alright, let's find out what this is about. I didn't know he wrote anything about, oh. Okay. Aristotle gives us the following statement of Plato's concept for the genesis of numbers. Ho gar arithmos estin ek tu enos kai tes duados tes eoristou. Okay, so let's see if I can remember enough ancient Greek to translate that. I think gar is 4, arithmos must mean numbers, is henos, and the duodos eoristou. Oh dear, my Greek is not up to this. But this apparently simple statement, not to me, unfortunately. I think this is probably you go from 1 to 2 and then keep going or something. With other related passages, there is a confusion or contradiction somewhere which no man has found his way through. And I begin to think that our first business is to inquire what is meant by number in this particular connection. Aristotle's statement might refer to the genesis of number in the widest sense, ordinary numbers 1, 2, 3. A question, the similar process of generation has never been shown to be related to the so-called aoristos duas. Irrational number, okay. Well, this is kind of interesting. Oh, we didn't go any further with that. Well, I think that's interesting. I'm clipping this out. I want to go find more about what he did there. I'm assembling a little clippings file here. Okay, let's keep going here. Well, that was interesting. Oh wow, it's always fun to find little fragments of Greek in the middle of this, in the middle of the math. I guess people did read Euclid in Greek as their math education until fairly recently. But okay, so he's studying. What is he studying? Alright, let's go down here. What is all this? This looks like pretty elementary number theory stuff. Alright, let's see what happens here. The shape of the heavens is that which is best, i.e. most appropriate to the creature which is to contain all other creatures within itself. It is therefore spherical, because the sphere contains all figures in itself. Interesting. The schemata, oh wow, there's the original word for schemata, I didn't know it in Greek, alluded to the famous 5, regularly called in later antiquity when it's proved by Theaetus and his associates, blah 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 blah, that these 5 and no other regular solids can be inscribed in the sphere, the figures of Plato. It's interesting. Ancient tradition was that Pythagorean precursors of the Academy, knew how to inscribe these figures into the sphere. Okay. Alright, I still think this is not super exciting. Let's see what happens next here. These words are very significant. Epe, metakiti, sunesis. Oh, I see. No, I don't know that word. They definitely mean that the audience, including Socrates, are abreast of the latest mathematical researches of the time, and will therefore be able to follow the exposition. Okay. So this is about rational square roots, irrationality of square roots. Interesting. Okay. Well, let's keep going here, see what else happens. Even more ultimate. Timaeus offers no explanation of this hint that there are starting points even more ultimate than the triangles, and that these are known only to God and to men who are God's friends, i.e. philosophers. We can therefore only conjecture his meaning, but I think a reasonable conjecture may be made. Timaeus is a Pythagorean, and that the ultimate archi of the Pythagoreans were Peras and Apiron, which I don't know what they are. Blah 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 blah. I don't know. What is he talking about? What is more elementary than the triangle? Maybe it's the line. triangles. Okay, now I'm curious what's going to happen here. Replace the triangular formula pattern by the numerical formula which it expresses. Ultimate law for the number series itself. The Pythagorean, what the quotes friends of God know is just the great Pythagorean science of sciences, arithmetic, for our theory of numbers. For our immediate purpose, the construction of the corpuscles, which we may content to confine ourselves to geometry and to take two spatial patterns as ultimate. Blah 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 blah. Oh my gosh, come on. Which is called a gift brought by a Prometheus from heaven. The Pythagoreans are spoken of half seriously, half playfully as, can't translate this Greek, Kritones, Hemen, Kai, Egetero, Theon, that means God, Oikontes, might be something about a house. Don't know. Why is this allusion made in this mysterious fashion? Well, it's certainly mysterious to me. It would be irrelevant to rake up tales of late writers about the secrecy with which the Pythagoreans concealed their doctrines from the outside world. Okay, we're not learning anything here. Come on, man. Tell us something. Discovery of irrational magnitudes, blah, blah, blah. The correct passage of Timaeus is talking about. Come on. And now we get to the end, and now we're in the Loculus of Archimedes from 1926, Nature magazine. Wow, that's interesting. In the course of study, a totally different subject, I came across a pastime in ancient Greeks and Romans which was the same nature as the Chinese puzzle of tangram, though more elaborate. I didn't know they had tangrams. Oh, wow, that's funny. On a method, I don't really know German, so well, Heron, I would guess, was of Heron's theorem, but this is interesting. That person, Otto Neugebauer, I knew him when I was at the Institute for Advanced Study. He was very old then. He was to be seen, his office was near mine, actually. He was to be seen wandering around, often carrying index cards, which I know were index cards where he was decoding all sorts of tablets of Babylonian mathematics. So it's interesting to find this connection. Okay, so that was from 1938. Okay, well, I knew him in 1983, so a little while later. All right, let's see what he was talking about here, if I can tell, because I don't know German. So he's quoting Strabo's geography there. Okay. Oh, I see. So this is about the golden ratio. This is something about Phidas, who was said to have used the golden ratio to construct the Parthenon, if I'm not mistaken. And here we seem to have a real-life collection of hexagons and triangles. Okay, I don't know what those are doing. Yeah, yet more geometry stuff here. And there are the Platonic solids, and rather poorly drawn, I guess. Maybe they're not. Icosahedron, that should be. It looks, maybe it's not a very good one. Alright, let's see what else happens. I think we're still in the geometry section. Oh, wow. I didn't know he knew Arabic. Huh. No idea. Or maybe he just copied that from somewhere. Well, I haven't any idea what that says. Be great if there was somebody on the Twitch stream who could read that. Don't know what that is. Well, we're still in the in the polyhedron section. I want to get out of the polyhedron section. Yet more polyhedra, yet more polyhedra. Polyhedra, polyhedra, polyhedra. Gosh, there's a lot on polyhedra here. Let's find out what this is. I'm guessing that's a plot of whether there are polyhedra available with certain numbers of faces and vertices and so on. Let's see what this is. Yet more polyhedra from 1931. Now that was long after he'd written the first edition of the book. There's a picture of Luca Pacioli, patron saint of accounting and other things. Okay, let's see the natural logarithm we see there. What is this? So this seems to be a book. The development of trigonometric methods down to the close of the 15th century. Okay. Why has he got all this stuff? I mean, this is the product of three reflections by Coxeter. Okay, so he became he's a very famous geometer who died at a very ripe age recently, maybe 100 or close to it. English and mathematics. What is this about? From the Board of Education, printed by His Majesty's Stationery Office in 1924. 2d. Okay. The address given Mathematical Association, blah blah blah. The suggestions were intended primarily for teachers in secondary schools who thought the address may be on the use of English in relation to the teaching of mathematics. This sounds interesting. Okay. The report on teaching of English in England lays great stress on the important truth the use of English concerns all teachers. I see. So maybe this is a pitch for writing essays in mathematics. Okay, hold on. The study of mathematics has contributions of great, even of unique importance to making towards training in the use of English. Wow, this is interesting. Okay, this goes in my clipping collection here. The premature introduction of any subject is of course mischievous, and it must be admitted that mathematicians have erred grievously in this respect, but they are not alone in their error. But is mathematics a difficult subject? Absolutely, of course it is, as is every other subject when the aim is high. Perfection, even excellence in any pursuit, is difficult. But when people say that mathematics is difficult, they generally mean more difficult than... Let's hope I've got another page here. Oh, so sad. Okay, I need to get more of this thing. I need to make a note of that. Need more pages. I want to know what happens next in that one. Mathematicians and Poetry and Drama from 1939. Reprinted from Science. It's an American journal, so the Brown University. Okay. Well, these are all very late. I really want to find stuff that is much earlier. Man fell with apples, and with apples rose, if this be true, for we must deem the mode in which Sir Isaac Newton could disclose through the then unpaved stars the turnpike road. I can never read poetry. Okay. For all kinds of mechanics, and full soon steam engines will conduct him to the moon. Most curious. Okay. With most cordial regards, Brown University, 1936. Okay. Summary of the history of mathematics. Alright, I don't think we need to look at that right now here. Alright, what's this here? Daily Memorandum and Engagement Book in 1937. Okay, that's interesting. So this may be, okay. The telephone at the Charing Cross Hotel appeared to be Temple Bar 9191, and telegrams could be sent to that address. Okay. Oh, look at that. In 24th of December 1936, back from USA. I didn't know he'd ever been in the USA. That is very interesting. Oh, actually, I did know he'd been much earlier in the US because he was involved in the seals and studying seals in the Aleutian Islands. So I suppose he must have been in the US then. Okay, these are always interesting to see for people, the date books. For London, okay. Hard to know. He doesn't seem to have written a lot in his date book. I would guess that says Science Faculty 310. Whoever RSE is, we may never know. Something or other lecture. Something or other at 5 p.m. Okay. Dundee, somebody's wedding on Wednesday, 11 o'clock. Wow. Oh, Ash Wednesday. Maybe that was a holiday. Okay, well, we may not be learning so much from these date books. Not a lot going on here. Glasgow Mathematical Society. Term begins, I think it says there. Yeah, this isn't too exciting. Ruth goes back. Ruth was his daughter, one of his daughters. Okay, Ruth goes back to something. In 1930, she must have been fully grown up by that time. I think she taught at a school for like 50 years. Alright, I don't think we're learning much from this. Well, that means he was in London, because W8 is a district in London. Who knows? Marlborough, 8:30, I don't know. I don't know where the train lines went in those days. Oh, that's cute. Oh, I didn't know the 23rd of June. 23rd of June is the birthday of Mathematica's birthday. It appears also to have been H.M. the King's birthday from 1894. I did not know that. And I suppose that symbol means it's a full moon at 22 hours 59 minutes. And what is a quarter day? Maybe that's something to do with the solstice or the equinox? It's close to the solstice then. Okay, Copenhagen tetrapods? Weird. Alright, hard to know what we're learning from this. These are often much better when you see the date books of people. It's I think this is not useful. Okay. Oh, the diary of 1933. Complete with St. Swithin's Day. Oh, the Mohammedan New Year. Okay, from 1352. It's interesting that they would mark that in here. Okay, there's more and more and more date books. I think I asked my archive photographer to get some pictures from date books, but I'm afraid there's not as much that's exciting here as I had hoped. Note that in too large tortoise, something by hand. I'm pretty sure that says flamingo. Okay. Yes. There's something of the flamingo with its neck, etc., standing on one leg on a tree. Okay, very curious. Hard to know what the significance of that is. This writing is definitely not the easiest. Okay, now that is much earlier. Oh, that's interesting. That's must be from 1884, and that Ernst Haeckel is the guy who made a famous book. I did not know that D'arcy Thompson was acquainted with Haeckel. He made a famous book, which, among other things, had of biological organisms under the microscope, particularly about had some great pictures of radiolaria, little plankton thingies that D'arcy Thompson then started. Okay, I clipped that out for my scrapbook here. What is this? What on earth is this? Well, that looks like it's the manifest from some conference. But what conference? One has no idea. I don't see any particularly famous names. Oh, there's Arrhenius. Oh, there's a famous name. Arrhenius, of Arrhenius's law in chemistry. Rate of reactions and so on. I think later in life Arrhenius got very big on panspermia and an origin of organisms from other parts of the universe. Okay. What else is here? Well, it's hard to know what this is. Oh, there we go. Haeckel was there. Oh, T.H. Huxley. So whatever, and J.B. Haldane. Okay, so these are famous characters at something. Let's try to find out. Oh, and there's Glacier also. Okay, this is definitely a interesting gathering. I wonder what it was. Glacier was a mathematician. Thomas Huxley was Darwin's bulldog, as Darwin called him. J.B. Haldane was a uh, chemist, biologist, really geneticist. All right, let me just see what. Can we figure out what this is? Oh no, seems not. Okay, this is from 1901. Let's see what's here. My dear Dr. Thompson, I was very glad to have a letter from you again, and in answering it, I must first congratulate you and Dr. Kalman on your catalogue of Crustacea. It represents a lot of good work. I am glad that Dr. Kalman is doing Crustacea for so-and-so's textbook, hyphenated textbook in those days. A better man could not be found for the work. As regards exchanges, I am not doing anything at present, as I have applied for furlough and hope to spend the better part of 2 years after April next in England. I will go hard with me if I do not find time to pay a visit to Dundee. I don't know what that means. I am sorry to say that I've done nothing more to my crustacean catalogue, owing partly to ill health and partly to having had to fight a great deal to free myself from the from the vexatious meddling of a board of amateur nonentities. The result of my pugnacity is, I thank all the gods, that the museum will soon be entirely in professional hands. Okay, I wonder what this is. This is okay, so he was having a fight with his board at a museum. I'm afraid we've heard of those at other times too. Why zoologists should always be supposed to require to be tied to the apron strings of trustees, while botanists and geologists and meteorologists are allowed to manage their own affairs, is an insoluble riddle, unless the answer to be that zoologists are peculiarly tolerant people. My few hours of peace during the last 6 months have been devoted to the deep-sea Madreporium of the Ciboja Dutch East Indian expedition. Okay, I hope we shall be able to arrange a meeting sometime during the next 12 months. Do you know anything about the Chair of Natural History at Glasgow? Okay, I saw in Nature some weeks ago. Gosh, they had ads for jobs in Nature back then, 100 years ago, 117 years, 17 years ago. Okay, so this person was thinking of applying for a job there, I guess. Okay, so let's see. This looks fun. Okay, oh, this is from Calcutta. So this is somebody. Okay, so this is so whoever this is from 1898. I enclose a list of 64 species of Crustacea, of which specimens have been packed for your museum. Well, it's always, you never know when you'll need crustaceans packed in Calcutta in 1898. One just wonders whether they're still in the same. You find these things in museums that come from very ancient times. Natural history museums, I mean. Let's see. Okay. All right, 1885. Dear Sir, in reply to your letter just received from Sydney, interesting. It's interesting. Oh, from Melbourne. Okay. From H.M. Customs in Melbourne, Victoria. Okay. In reply to your letter just received from Sydney, I have much pleasure in sending you a copy of my catalogue along with a former paper on the hydroids, maybe? When the earlier paper was published, I sent a copy to London for you, but your friend who received it failed to find your address during the short time he was at home. I shall be very grateful for the response you kindly proposed sending me. So and so, maybe bail or something there. I can't read that. And that's out of focus, unfortunately. Okay, 1890. French. Okay, I have received. J'ai reçu. I'm not going to try doing my French accent because it's just too awful. I have received from my colleague so and so your numerous and very interesting letter. Blah blah blah. Who knows? Looks like just a thanks for sending me your stuff. The Zoological Society's Gardens in Regent's Park, 1878. Boy, this is early, this is much earlier. So he was born in 1860. So that will have been when he was 18 years old. That is interesting. That is interesting. I am directed by. The. I can't read it. Bartholet or something, to acknowledge the safe receipt of the sparrows you have been good enough to send, and to inform you that he believes they are quite new to our collection. A letter of thanks. Okay, so when D'arcy Thompson, that's very interesting. So when he was 18 years old, he must have sent some sparrows, presumably stuffed, I would assume. Okay, 1889. Many thanks for your studies from the Museum of Zoology in Dundee. Blah, blah, blah. From Leipzig. 1839. Okay, I don't know what that is. From Padova. So and so. It's in French. That doesn't look very exciting. My dear colleague, from the Congrès International de Zoologie, the International Congress of Zoology, in 1889. So D'arcy Thompson would have been 29 by then. Okay. Doesn't look too interesting. Who signed it? We can't tell. Well, I wish to transmit to you the sum of 30 francs. Who knows? From 1896. There's a lot of French in here. I guess people just wrote that routinely. For a publication which I'm preparing on something or other, I want to know whether you have also written on the same cetacea. I don't know what those are. Maybe they're crustaceans. No, cetaceans. Cetaceans. Yeah, I see. Risso's dolphin, a cetacean new to the Irish fauna. Blah, 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 blah. Okay, so they want to know whether he's written something on that cetacean. Thanks for the specimens you kindly sent. You're a brick. What? You're a trick? A brick? Who knows? If I can only feed some things in exchange for your gift, shall be accounted blah, 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 blah. Fishes. Hard to know. Okay. What on earth? I am very much indebted to you for the fetal beluga, which arrived safely in 1896. Okay. I guess in those days, sending, let's see. So we'll be leaving, I wrote to you, I have been on a trip, blah, 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 we'll leave in 10 days, blah, 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 blah. Well, the fetal beluga seems to have arrived. Okay, 1895, so that would be, oops, where did I left off, where did I go here? Where was I? So in the center, I'm not sure how this works. Have I seen this already? Yes, I have. Okay, that's the fetal beluga again. Something or other, a specimen. So this is a lot of stuff on specimens being sent back and forth to museums. I'm glad to hear of your intention of competing for a natural science scholars at Cambridge, 1880. So he was 20 years old at that time. Okay, that's sort of interesting. I didn't know. I guess that's when people, maybe people went to, well, let's see. I sincerely trust that you will get it, not on your own account only, but for the sake of science, also for I know of no one better qualified by natural ability through training to do good scientific work than yourself, nor do I know anyone more likely than you to utilize to the utmost every faculty and opportunity, and not let your powers rest in idleness. Blah blah blah. Believe me, yours very sincerely, somebody whose name I can't read. Okay, so it's you should apply to college in Cambridge or graduate school or whatever that corresponded to. Many thanks for the 2 skins of the Calocephalus from Alaska and the walrus head. Oh dear. And the walrus head arrived yesterday in good order. Okay. It's sad for the walrus, no doubt. Several collections of Indo-Pacific crustacea. Okay. Director of the Zoological Museum of Zurich, maybe? Of Turin. Okay, American Museum of Natural History. That's amusing. Okay, New York City, 1897. From the Department of Vertebrate Zoology. My dear Professor Thompson, the photographs were duly received, and I beg to thank you for forwarding them so promptly. They... something. Interesting, anything I've ever seen, and I will endeavor to make copies which will do them justice. I wonder what they were pictures of. Okay, well that's interesting. That's I guess there we go. Is the American Museum of Natural History still at 77th Street and 8th Avenue? I think it is. I think that's about right. Okay, let's see. Well, it's the end of that one. Okay. That's 1931. Okay, that's interesting. That's when the phone numbers in England were very, very different from today. No direct dialing. It was reach Station Ockley and ask for 5 Ewhurst. Okay, my dear D'arcy Thompson, how can I thank you for your very kind and sympathetic letter? My dear wife always remembered and liked you. She had a great blah 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 for classical, and is so, I see, so this is probably a response to a condolence letter. Yes. We were, but happy life together of 47 years. So I can't read that. Okay. Olivet College in Michigan. Oh, I think that still exists. Okay, 1900. My dear Professor Thompson, at last the small can of holothurians which was sent to me last May has been received. It arrived in Olivet some days ago, but on account of the heavy charges on it, I declined to accept it and wrote to Pitt and Scott for an explanation. All charges are prepaid. I wonder whether were those customs or were they shipping charges. Some of the charges, on which notably brokerage, seemed to me excessive. There was no need of paying any duty, but this statement reached me too late to make an appeal. Blah 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 blah. Okay, so the creatures were stuck, and it was there was a problem with shipping. Okay, well, fine. Okay, 1896, County Donegal. My dear sir, thanks for your kind offer to lend me a slide of such and such. Okay, more museum-y stuff. Dear Professor Thompson, this is in German, so I can't read it. Belfast, 1884. Unexpectedly, share reached home, which was earlier than anticipated, when we met at Queen's College, Galway. Blah 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 blah. Various kinds of trips to some bay. What on earth is this? is this? With this I enclose a sort of rubbing of a brass. Oh wow. Recently found in a bog near Uktare. Date is 1011. But as of the legend, or whatever it may be, around it, it is very different to make head or tail of it. It's difficult to make head or tail of it. Seeing the date 1011 is in Arabic figures makes me suspect that it is not a genuine antique. You don't say. You don't say. Yeah, I don't think Arabic figures reached... that's a funny mistake for somebody to make. Fibonacci was the one who brought, in 1200, around 1200, 1205 and so on, brought most of those things to the West. Okay. Well, okay, so it's a fake. Okay. 1896. Can't read it, German. Okay, great interest in blah 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 blah. It's just a platitudes letter. 1899. Let me thank you for your friendly letter. The specimens of Leucermians, blah 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 blah. 2 specimens of Salamanderi. Okay. You send me a Lucimanius, whatever it is, and I'll send you a salamander. That's cool. Festschrift volume, etc., etc., etc. Department of Agriculture, Cape of Good Hope, Cape Town. Alright, very little to share, collection, blah 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 blah, marine station. Doesn't look very interesting. That's Museum of Comparative Zoology, Cambridge, Massachusetts, 1896. Well, I've certainly been to that museum. At least I assume it's the same thing as the... Okay, many thanks for the... You know, one wonders whether one just finds everything that was sent by D'arcy Thompson is still sitting in a jar somewhere, although its label might be peeling off. The Smithsonian Institute at Washington. I fear the Institute is rather slow in something. Read us in something. I can't read that. Okay. That looks like a Dutch museum. By request of the Director of the Museum, oh my gosh. I have forwarded to you today 1 box of 11 birds in exchange for something or other. I see. So there was a lot of bartering of stuff back and forth here. It's interesting. I didn't really know that. Okay, 1893 from Zurich. 2 female something or others and 2 male and 1 hermaphroditic something or other. Don't know. What is that? Swedish. Oh, it must be some... What the heck is that? I mean, there were stamps. Why wasn't it just stamped? Oh. Cote Reserve à l'adresse. Okay, so... I don't know what that is. Maybe it's... Oh, maybe it's registered mail. Maybe it's registered mail, where the return receipt... I bet that's what it was. I bet that was a return receipt requested. Okay, yet more papers on hydroids from 1906. What is this? Okay. The Council on Education thanks you for sending a specimen of the something or other. Museum in Hamburg. Okay, so he's got museums all over the place. Oh wow, where's this? Where is this? Nikoliski. Am I reading that right? Edvod. I'm confused. I don't know where this is. Maybe that's a person's... I wonder, I don't know what letterheads look like there. That's from 1904. The Tsars were still in power. Oh, there's something Nicholas. Okay, so Nicholas, which is what I think that word is there. Don't know. Alright. Annual meeting. Members travelling by Cunard. It's a shipping line. I think it still exists. In Toronto. What was the British Association for the Advancement of Science doing in Toronto? I guess part of the Commonwealth then. Oh, very swank. Not quite as swank as the Titanic, but perhaps that's just for the better. Oh, that's kind of cute. That's kind of a cute idea, that everybody going from England went on a big boat. It kind of beats the chartered plane. Oh, Lord Rayleigh. That's interesting. Okay, let's see who was on this merry charter. Well, Lord Rayleigh was number one. Where was number one here? No, he was the big fish, so he was in the middle there. Any other names we recognise? Galton was probably not, since it said Captain Galton, was probably not related to Francis Galton. Let's see, anybody else of particular note? No. Mr. William Thompson, number 31. Mr. William Thompson, where is Mr. William Thompson at number 31? There he is. Barely visible, actually. That is the person who became Lord Kelvin later on. At least I assume it is, unless it's another William Thompson. Oh, very, very swank. Looks quite. Oh, list of... Okay, these are always amusing to see. List of passengers, printed. Mr. Julian Huxley. Okay. Interesting. Well, do we have Mr. D'arcy Thompson here? Sir, so-and-so, etc., etc., etc. Definitely don't want to miss out on any titles here. Well, there's a very fine one. A KBE, a DSC, and an FRS. No less. Oh, Sir Ernest Rutherford. There we go. And Lady Rutherford. Okay. Oh, look, Mr. L.F. Richardson. That's Lewis Fry Richardson, an early fluid dynamics person. Interesting. Oh, J.H. Priestley of oxygen fame. Okay, what is this? Itinerary for Sir D'arcy Thompson, 1938. Cross by the Harwich to the Hook of Holland. Okay. They're very precise departure and arrival times. I wonder if they kept to those. You will be met everywhere at the station, so it will be necessary that you should adhere to this timetable as much as possible. The people meeting you will be wearing a yellow bow on their coat. I am sending you one too. Interesting. These days, I guess you'd call their cell phone or text them. Okay. Well, a very swank thing. To London. Okay. KLM Royal Dutch Airlines. Passengerless and Canary Islands steamers. 1911. Well, obviously these are from very different times because... What's this? Air France. What on earth is this? Why does it say... It basically says a company with a capital of 120 million francs. Why is it? Oh, member of IATA. That's the Airline Travel Association, which is, I guess, still going today. Huh. Okay. Staying at a hotel in Paris. Alright, fine. Stockholm, 1946. So that's very late. A postcard. Alright. Something from presumably the Netherlands, Utrecht there. Great, the centre of Utrecht. I wonder if it looks similar today. Okay, International Council for the Exploration of the Sea, Stockholm meeting 1946. Oh gosh, this is about boat trains. We don't need to know about boat trains. Visit Gothenburg. Okay, Air France. Okay, lovely. A very swank plane from 1946, Swedish Airlines. I wonder if that became SAS. Presumably those are train timetables. Maybe planes, probably trains. Wait a minute. Addis Ababa? My gosh, it really is Addis Ababa. That's a, okay, well this has to be a train. I think it's a train. No, it's planes. Wow. That's fun. So you went on a plane and it stopped in all those places, I guess because it didn't have fuel to go further. Why would it go Nepal? Where would that be? Naples, maybe? Cairo, Khartoum, Addis Ababa. Okay. Interesting. Okay, this is how much it cost in Swedish krona. Great. Okay, all sorts of lovely route maps. Hellenic Travelers Club. Great, 1934. Okay, 1933. Guide to the Netherlands. Hellenic Travelers Club. I wonder if he was doing that. He was pretty old by then. Let's see, he must have been in his 80s by then. Maybe he was doing one of those kinds of, well, okay, so this is 1917. Okay, now we're back in time. I have seen with quite unusual interest your work on the mathematical theory of population for Professor G.H. Knibbs of Melbourne, Australia. My own statistical work is the most elementary kind. May I suggest to you the name of Dr. Ridd of Copenhagen as a man who would be heartily interested in your book. Blah, 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 blah. Okay, so this is long before Fisher and people like that did their statistics stuff. What on earth is this? Now that is a strange thing. That is really odd. That says Mussolini, Hitler, Chamberlain, something or other, which wins, and it spells out Stalin. Wow, what on earth was that? And when was it from? I mean, this is on the back of a thing from 1917. What would it be doing there? Why would he be? I mean, maybe he was doodling. I mean, that issue wouldn't be something that would come up until the 1930s. But I don't know who this is. Daladier. I should know my history better. I do not know who that is. Let's see, your scientific investigation on the Aberdeen fisheries statistics. This is also 1917. The Commonwealth Bureau of Census and Statistics from the Department of Home Affairs. Oh, in Melbourne, so it's Australia. Blah, 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 blah. Blah, 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 blah. Who knows? Yeah, okay, so he wants to adapt his methods from Aberdeen to Australia. A Commonwealth, oh I see, so that's this person. G.H. Knibbs was a Commonwealth statistician. If the Earth be changing its configuration owing to large seismic disturbances, the question will still be further complicated. One is reminded of a dictum of Poincaré's, viz. That there is no limit to possible interpretations of phenomena. If we recognize that the fluctuations of mean sea level, as we know them, are merely differential, we can see easily that they may be attributed wholly or in part to seismic changes. In other words, the datum to which we refer them may be varying its distances from the center of inertia of the Earth. Although the fluctuation of the tangent to the geoidal surface produced by the moon's action is small. Wow, that's interesting. So this is so they were noticing changes in sea level, and presumably in tides, and they were wondering what they were due to. I mean, maybe they were observing global warming. Who knows? Let's see. Because they were observing tide. Let's see. Wow! Look at this. I have seen it suggested that possibly, this is 1917, that possibly variations in the snow and ice at the pole also affect the mean sea level. Huh. Okay, so if you account for the 18.6-year tide, that's the Saros cycle of the tides, and that periodograms give no very definitive indication of regular tide of the indicated period, your conclusion seems unavoidable, viz. That the phenomenon is complex, and that only through accurate observations extended over a very long period can we help to definitively know the nature of the mean sea level. Well, that's quite interesting. Quite interesting. Somehow nothing ever actually changes. Okay, let's take a look here. What is that? Oh, that's the height of water. Oh, that's tide measurements. Wow. Okay, that's tide measurements from February 1913. I wonder what the date in February 1913 is. Okay, now, can't miss this opportunity. Let's see if we can compute this. Let us see. Can't miss this opportunity. Let's see whether we can do it. Let's get up a Wolfram Alpha. So this is, well, this must be in Aberdeen. Tide. Let's just say February 1913. Can we do it? Can we do it? We're thinking, we're thinking. Aha! Oh, this is so cool. Oh no, but wait a minute. Aberdeen, Maryland. That's no good. Wrong continent. Oh, Aberdeen, United Kingdom. There we go. Let's try this. You know, there was a point at which the Admiralty Office was telling us that the tide tables were classified for fear of invasion, but they were available from the 1800s. Okay, here we go. Oh my gosh, this is fun. Okay, so let us see what we can figure out here. So this is, let's see, so this is Aberdeen, United Kingdom, February 1913. So that's the tide that we have there. Let's put that in this notebook here. So this now, well, first of all, show metric. Well, I don't know whether that's metric. I wonder whether this is metric. What do you think that is? Let's see. 140. What on earth is this? What on earth is this? 160, 110. Drat. I don't know what this is. Let's see what else is near there. Okay, here, this seems like more tide stuff. Gosh. It almost looks like it was printed out by something, but I don't think you can... Okay. Oh, tide gauge records. Okay. Report of the committee to assist work on the tides. Process of reduction of the tide gauge records has not been carried out much further in 1921, except the residues from a complete year's records are now available. The residual semi-diurnal oscillations are not yet reduced to law, and direct analyses have not been attempted, but two hypotheses have been considered. Blah, 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 blah. Well, okay, so this is from the tides at the Bay of Fundy, which has some of the most extreme tides on Earth. Okay, well that's fine, but let's see what is this? What is this? Okay, this is potentially exciting. Oh, except this is a residue from New Lynn. Okay, so this is in feet. Square feet? Why is it in square feet? The heck is it doing in square feet? Unless I'm misreading that. Huh. New Lynn. Where is New Lynn? January, but it's very beautifully plotted. Wow. But those I wonder what residue means. I mean, I wonder if residue is the full height of the tide relative to mean tide, to mean sea level or something. Let's take a look here. The resolution relating to tide gauges have been... Oh, that's also... That's interesting. Have been sent to Sir E. Shackleton in connection with the Shackleton Powit expedition. Well, okay, let's see what this is. Okay, this is a gauge. This is really hard to read. Tides in 1844. So this is some residue from the tide gauges in 1913. Hard to know. Let's take a look here, see what else we have. Blah. Hard to understand. Okay. Mean intertidal range in Aberdeen. Okay, that seems more understandable. Now, why would the mean intertidal range change so much? Well, okay, so there's that's right. In the 18-year cycle, you can have a change like that. Okay, but that should absolutely be computable by us. So let's see. Let's see whether we can get that. Okay, so let's see whether we can get that. So that is the intertidal range. Now I think I get to use some absolutely wonderfully new, let's see whether we have it in here. I think we probably don't. Tide data, no. I get to use a new unreleased Wolfram language feature. So let me start up a new unreleased version here and see if I can do this. Let me see. So let me make a new document here and let me make it a bit bigger. And I think we have a new function called tide data, which is kind of the fully computable version of things. Okay, so this is tidal parameters, alright, so let's take a look. Oh wow, those are all the components of the tide. So let's see, the intertidal neap tide, blah blah blah. What is low high tide? Okay, so this is the intertidal range. Mean high water. So let's see. High tide, highest. Next low spring tide. I don't know what this is. So what on earth is the intertidal range? So there seem to be a lot of... Let's see whether the word intertidal appears. On the page, not found. That's a bad sign. Okay, so this was the mean intertidal range, and I wonder what that means. I wonder whether that means... See, if that's in feet, that's a very small number of feet. If that's decimal feet, that's absolutely microscopically tiny. Mean tide level, average level of tide. Well, okay, let's just see what that looks like. So mean tide level, tide data. Oh, whoops, I need to go to the new thing here. Mean tide data. So let's see how this works. So we say, okay, so we can say Aberdeen there, I think. Mean tide data. See if that works. Oh, what went wrong here? Did I get the name wrong? Mean tide level. Silly me. Okay, lovely. Now let's figure out when we do that for a particular time. Okay, so there's a date spec there. So let's try just the year 1913. 7.47 feet. I have a bad feeling that this mean tide level is something which is mean for a whole station. Let's try the year 1914 instead. I don't think this is right. I don't think this is what we need. Let's see what happens. I wonder what happens if we say water level for a whole year here. Well, that's interesting. I wonder what that even means. Is that the beginning of the year? Or is that a time series? I mean, what I would kind of think it was. Okay, well, let's see what happens if I just try 1913 here. I mean, this might be for January 1st or something goofy like that. Well, let's just see. When in doubt, look at the examples. Okay, so this is a date range. All right, so what we can do here. Okay, this is a good example. So let's look at this by the day, just to get some idea, and let's do it for Aberdeen. Let's do it from January 1st, 1913 to 1913 December 31st. I don't know how difficult this is to compute. Oops. Okay. Wow, okay. It is kind of remarkable that one could just type in something and find out what the tide was like in Aberdeen in 1913. Okay, well, let's just see what happens if we were to pick. I think it's kind of silly, but let's just pick the months, all the months from 1871 to 1901. Okay, so let's go 1871 to 1901. Let's see what happens if we do this and see whether we can see anything useful here. Date list plot. It's kind of scratchy, but I have to say there doesn't seem to be an obvious. I mean, so this will be picking it at random times of the year, at times of the month, so to speak. And the question is whether this. And this is going from 0.5 feet to 2.5 feet, so a range of about 2 feet. And I don't think we could tell whether there was something of that magnitude there. So let's go on and see whether we can see some other things here. Many thanks for the volume, blah, 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 blah. Your curve showing the mean intertidal range of Aberdeen and does seem to indicate the possibility of a 50-year period. Okay, that's interesting. Okay, sent paper on mean sea level. Find it interesting, blah, 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 blah. It is quite true that Fourier analysis permits us to transcend our own senses and get results. Blah, 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 blah. Fourier analysis works wonderfully. From 150 years of observations of the moon, derived all inequalities of the moon's longitude. If you know the period, but if you don't, you are hopelessly at sea. I am no blind believer in periodograms. Yeah, well. Yeah. The periodogram. Okay, so he was trying to. So this is interesting. So he was trying to figure out an anomaly in the tides. Yeah, great. What do you mean calculated? How did you calculate that? Milford Haven. I wonder what year. Oh. Well, let's see, 1900. Let's just try doing that. Wherever Milford Haven is for 1900. Let's see if we know where Milford Haven is. Yep. Okay, so that's for the year 1900. So let's do it the daily prediction. Well, what was that for actually? That was, well, let's just look at the for Milford Haven. $1900. Let's do the daily computation there. Okay. Now let's compare it with what he was showing here. Well, whoops. Okay. Well, that was different. Sorry, that was a different piece there. That's the mean sea level in Aberdeen and Dundee. Oh, this was the one here. I have no idea what this is. This doesn't make a lot of sense to me. Doesn't make a lot of sense. Maybe it's the distance between low and high tides. Okay, well, I'm officially confused here. Okay, 1912. Oops. Okay, this seems more helpful. So this is 1912. High water. Okay, high water at the full moon. High water AM. But why are there so few data points? Oh, because they're for the lunar month. The new moon and the full moon. Oh wow. I wonder how we get that. Okay, fine. So that's cool. So we can, so that's I see. That's what he's doing there. So let's see whether we can compute that. So that was for 1912. Where is it for? Where's that for? I mean, I assume it was his local tide station. Yeah, so it's probably the local tide station in Aberdeen. Okay, how do we compute the full moon? Let's see, moon phase. But I wonder how we compute the time of the full moon. Gives the moon fraction, but now how do we compute when is the full moon? Moon position. You know, that is a function we should probably have. Is compute when the full moon is. I do not believe we have that. Unless moon position will give us that information. Does moon position give us that information? Am I being stupid? Let's see. Can you deduce the moon position? Can you deduce the phase of the moon from the moon position? Let's see. That is interesting. Okay. I thought we had a way to do this. Okay, well let's do this. Let's get the moon phase. How to do this? Well, we can certainly have a date range. Let's do this. This is kind of cruddy, but let's do it anyway. So this is going to be the moon phase through 1912. The daily moon phase through 1912. And let's go ahead and do moon phase for that date range. Come on, why is that taking so long to compute? That's odd. Well, let's try doing, maybe it takes a while to compute the moon phase for a time that long in the past. Why would it? I don't think it's that hard. I mean, computing the position of the moon is always hard. Oh, there we go, 366 points. Okay, so now let's go ahead and say, so we want to get the time of the new moon and the time of the full moon. So the time of the new moon is Well, let's first of all do a date list plot of this just to see the moon. Okay, great. Okay, so now we want to find the minima of that. So I think we just have to do, let's see what happens if we just say find peaks of %13. Okay, so let's see what happens there. Magnificent. Okay, let's see how many there are. See whether there are the right number of 13 lunar months. What do you know? Okay, so those are the times of the full moons, because they are the moon phase when the moon phase is maximal. So that is the time of the full moon. Those are the dates of the full moons. Okay, so what we want to know is the morning and afternoon tides on the dates of the full moon. So for that we need to go back to tide data and let's see. Next high tides predicted. Okay, so I think high tide. Alright, so what we want to do here is take first of each of those things in line 16, and then we're going to want to compute the high tide in tide data of Aberdeen, high tide, and then let's just do the very first of these just to see if it's working. Aha, there we go, 9:20 in the morning, 1.268 feet. Okay, let's do all of them. Line 18, okay, so let's go ahead and do those. And meanwhile, let's look back at this. So 1.268 feet is to be compared to, so that is the first, HT is probably high tide, high water, yeah. So 21.4 in the AM, 21.5 in the, okay, so let's take a look at those. Okay, so 686 data points, wow. Okay, let's just see what those look like, date list plot. Oh, interesting. Okay, so that's the variation of the high tides over the course of the year at the times of the full moon. It's interesting that that does look actually a little bit similar to some of these other plots that we've been seeing. So maybe what those are the tides only at the full moon, and that's why they don't look quite the same as before, as the other ones we were computing. So let's take a look here. This one was, does this look anything like that? Well, that was for a different place in a different year, so it's hard to tell. But let's go look at this one here, and let us take a look at what those, I see there are a lot of high tides here. We need the high tides right after the full moons. Why are we getting so many high tides? That is very curious. Well, I want to see whether the 1.268 feet. So unit convert, let's say 1.12, let's just pick that up there. 1.268 feet. Let's convert that to inches. 15.2 inches. Well, we've got 21.4. Let's just see if he was being modern. Let's just try and see what happens if I convert that to centimeters. 38 centimeters. Okay. Nah, that wasn't the explanation. Alright, well, I do not know. Of course, he might have had a different origin for, so let's see, 1, 2, 3, 4. Okay, so the fourth month was different by a significant amount, although that was the first high tide in the fourth month. 1, 2, 3, 4. Let's just see what that is. Okay, so here it would be this computation, but now for for this case here. Interesting. Not promising in terms of agreeing with that data, but interesting nevertheless. So that is 2.5 feet, and what this data was saying was that the number there was smaller. So I'm really confused. All right, don't know what's going on, but it's clear we should have the wherewithal to be able to figure this out. Okay, hold on. Let's take a look at some of these other things here. Annual fluctuations, 1887. Well, that's a beautiful sine wave. I wonder whether any of that was true. I don't think so. I think that the tides really do repeat on an 18-point-something year cycle. Okay, so that's with respect to some datum. The datum is kind of the level of the zero level for the geoid. DA. I don't know what that means. Oh, I see. Dundee and Aberdeen, and that's the difference. Mean sea level. Do we have a mean sea level? Let me just take a look. In here. Oh yeah, we do have a mean sea level. Oh, very interesting. Okay, so let me just take a look there. Now I'm curious whether the mean sea level... Let's just look at the mean sea level for that range of values. Whether we can get something interesting there. Now, no, it just says 7.5 feet. So it's not saying, I see, that must be, it's a question of what you're averaging over. So that's the average is 7.5 feet. Oh, this is something completely different. This is the number of haddock caught in Aberdown Bay in 1903. Okay. Now I know this stuff from including such and such a number of haddock, so something is shown separately. Well, what is this? Is this as a function of day? It's a little weird that this has numbers like that on it. Difference from Aberdeen to Dundee in mean sea level. Okay, but this is now very different kinds of things. These are the number of haddock fish that are being caught. 4 hauls of haddock fish. Somehow very Scottish to be catching haddock. Let me see what these are. More haddock. So what was he trying to work out here? So this is probably the size of the catches. Maybe as the let's take a look here. What was this? Haddock. How can he think that the haddock had some kind of sinusoidal variation? That's crazy. That's just weird. 1903. He seemed to be saying, well, unless the number of haddock varied with the tide somehow. Maybe it does. I can't imagine it. Alright, there's more stuff here. Let's see, what is this? What on earth is this? These are people's dates, it seems. There's nothing to do with haddock there. Alright, what's that thing there? Oh wow, these are people. This is dates of random. What is the... Well, I see. So this is some kind of estimate of the number of something or others. Titian and Botticelli, obviously painters, so that must be some kind of estimate of like the number of painters alive as a function of date from 1400 to 1600. So he was definitely into time series of various kinds. What's this? Oh, this is just working out who was around at those different times. Okay, so we've entered a new subject here. So these are okay. What is this? That looks fun. Oh wow, it's a kind of cool timeline. We can make those plots too. Oh wow, I want to reproduce that one. That is... I'm just going to see whether that works. If I say something like Italian painters in the 1500s. I'm not sure if we can do this yet. We're going to be able to do it soon. This is looking bad, the fact that it's not coming back. No, we couldn't do it yet. We will be able to do that soon. That's going to be cool. Okay. The Golden Ages. Empires perished before recorded history began. Ruin comes, but resurrection follows. Magnus ab integro saecorum nasciter ordo. I think great something or other help is born. No, my Latin is not quite up to it. When astronomy, the first of the scientists, discerned the cyclical movements of the stars, it was easy to conclude that they controlled the revolving fortunes of men. That's kind of interesting to make that analogy. Yeah, it's kind of interesting. Okay. Philosopher whose teaching has dwindled down to substance of 2 words may have said panta something or other. That's all. I don't know what that word is. Maybe say all things flow. Okay. Yeah, that was Epicurus or somebody. I don't remember who said that, but blah blah blah. Okay, this is a little bit on the pompous side, but let's keep going. But as in art, we see most clearly the existence of a period or school. Okay, so that's interesting. So he was trying to study. He was doing digital humanities long before. That's kind of a cool example in digital humanities. Digital humanities before there was anything much digital. Long, colourful history of Italian painting. Blah blah blah. It is an epitome of a larger something or other, for it is to be I included some 60 lives, all of something or other men. Which or something, hard to tell. Okay, so this is yet more of this. Nigh 80 years ago I stood by my grandfather's knee while he talked of the wonderful 19th century and all the changes it had meant for him. Okay, so this must be when he was later in life, because 80 years ago, the 19th century, so told me many journeys to Italy, blah 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 blah. But we may turn from the marketplace and the patent office to the familiar faces of the few immortal men. Okay. Oh, so this must be later. Planck and Einstein, Gauss and Riemann, etc., etc., etc. Helmholtz and Claude Bernard. All of these are hero bred, so this must be much later. And what is this? Mean sea level in Aberdeen. We're back to tides. Oh, there we go. That looks like a tide plot. Difference from mean. Mean low water and mean high water. This is great. This we should be able to reproduce, if only we know what year it's from. Don't tell me we have to use some kind of machine learning thing to figure out which year this could be. By just looking at the picture. Okay, mean high water. Come on, it's got to say the year. Say the year. 1918. Okay. Okay, we are really cooking here. Mean high water 1918. Okay, we are going to be able to get this. Alright, this is what we are going for. So there's that, and now we want 1918. We want the daily. I don't know what mean high water. Let's take a look whether there's a thing called mean high water. Mean high water. There we go. Location specific properties, but mean high water might be a fixed level. Okay, maybe it means something different to him. Let's just see. Line 18, okay, hold on. So we want it for every day in the year for 1918. 1918, beginning of the year to the end of the year. Alright, let's see what happens. Oh, come on. Well, let's see what happens if I just ask for high tide here. Because he may call it mean sea. Let's do low tide as well. And let's see. Why is that not available? Low tide. That's really odd. Well, let's see what high tide looks like here. That's that thing we got before. And that is, so I wonder how many, I wonder what the, let's see what the scale is on this thing. That seems to say -13. What is that saying there? 12, 5, 13, 9. What is that? I don't know what those days are, but probably every dot is a day. Okay, this will have to be analyzed separately. Alright, I've got to keep going here and just look through. Okay, we're actually getting close to the end, which is good. 1862. Wow. So there must have been a tide station. Milford Haven tide gauge. Okay, difference of mean monthly sea level from mean of the year. I wonder what they meant by the mean monthly sea level. I mean, maybe there was some way that the gauge averaged over time during the year. Footnote. Oh, look at that. Tidal phenomena. We have a formula. Oh, that's interesting. So the epoch, so basically he's trying to fit the tide to essentially a trigonometric series, which is what it does fit to. What is this? Hard to know. K2. I wonder if K2 and H2 are tide-related quantities. Let me just see. I think we had this whole collection of tide. K2 and H2. Okay, there's a K1. I mean, I have no idea whether these things... Oh yeah, there's a K2. Lunar Solar Semidiurnal Constituent. K1 and H2. Was it H2? I think it was H2. Yeah, well, so I bet those are the actual... So I'm sure those things haven't changed in terms of their nomenclature. K2 and H2. Huh. So those are tide components. Yeah, those are those tide components, presumably. Alright, let's take a look at what else there is here. The Royal Society. The Relief Committee. Okay. What? The Relief Committee. Scientific Relief Committee. 1942, middle of the war. In London. They were probably being bombed at the time. Okay. My gosh. With reference to minute 4, to report that Mrs. Cowper Cole's income exceeded £300, the grant had not been made. Blah blah blah. Had been withdrawn. Mr. Orling having obtained a grant from the Royal Bounty. Okay, well, who knows? Seems like administrative nonsense. Meeting of the Scientific Relief Committee. I wonder what the Scientific Relief Committee was. What does it mean? What on earth does it mean? I don't know what this means. Well, who knows? 1931. weight length formula in place of, so this is a, oh, it's interesting. So he has these power laws of weight length type stuff, which is something that became very popular later on, of power law relationships between different quantities for critters. Okay. So he's showing how you do that computation. Okay. Euler. So this is the number of faces. That's generalizations of Euler's law to a body of n dimensions. Great. Ah, geometry of the silicaceous skeletons of the radiolaria. That's a famous piece of work. Haeckel. These colonial forms are well known. They were first found by Huxley on his voyage of the rattlesnake. I see. Okay. Yeah, people have figured these out. These are aluminosilicates of some kind. But it's only very recently that Plato's... Okay, this is cool. So this is where he was talking about one such case. He described it in growth and form. Yes. Lots of stuff. So he tried to make the analogy between a soap film, which forms a minimal surface, and the shapes of these radiolaria. And there's a very bad picture of a shape of a radiolarian. Okay, surface tension as a way. Okay. So number of regular facets in the polyhedron. Okay, fine. What is this? 1937. Snow crystal or snowflake from somebody else. What is this? It's the shape of some critter or another. What is that? Looks like a claw or a hoof. Great. Gilbs absorb. 1940. Gills, blah 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 blah, semi-permeable membranes. Okay, so that's pretty fancy, but don't think that's seems to be some talk somebody else gave. The motion of the limbs in walking or running may be regarded as examples of the dynamical problem of coupled systems. Yes. The more general problem of coupled oscillating systems is treated in Lord Rayleigh's Sound and in textbooks of advanced dynamics. That's kind of fun. That's so people do study that. In fact, somebody at our summer camp, a high school kid at our summer camp, made a very nice study a few weeks ago of walking and running behavior. She really made a pretty nice demonstration. Okay, magic squares. Okay, fine. 1937. It's Italian. I can't do that one. Something about magic squares. Why he was interested in those, I don't know. Okay. Great. Gives a beautiful something or other. Oh, Punic square? Oh, no. No, what is that? So that's probably for experimental design, for figuring out. Well, I don't think so. A good one. Okay. Department of Natural History of St Andrews. A lovely magic square displayed on that. I assume it is a magic square. I'm not going to check. Okay, more and more magic squares. What is that? Oh, that will be showing the trajectory in the magic square of successive numbers. It's kind of cute. It's a nice visualization. I've done those myself. Easy to do, but it's kind of cute. So I wonder if he was trying to figure out if there was a general form. That's kind of interesting, actually. I mean, that's reminiscent of various kinds of various kinds of substitution systems and other discrete ways to make geometry. All right, let's see what else there is here. Theorems of numbers from Lebesgue. In a square divided into 16 cases. Blah, 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 blah. Blah, blah, blah. Edinburgh, I received with interest the magic squares which you sent me. Okay. Oops. More squares, more magic squares, okay. Now I'm going to find a cellular automaton in one of these. No, I'm not. It'd be really fun if I did. Okay. Yep, more magic squares. Why did he care about these? Why did he care? What is that? Some kind of duplicated magic square. I don't know why he was doing that. Let's see. Well, there's a strange object. Wow. Maybe there's zeros. No, I don't understand this at all. Okay. Let's see whether anything enlightens us in a simple bordered square. Who knows? So it's some other way of adding stuff up. The Study of the Sea from 1920. With but little truth and less of justice, it is now and then made a reproach to scientific men that their ways are narrow and their work, as we call it, specialized. That we talk in a language not understanded of the people and live each in his little hutch, wherein each nibbles all day long his own particular carrot. Yes, I think that could be said. Could be said probably even more today than in 1920. Okay, well, let's see what he's got to say about that. I see. Oh, that's interesting. Oh my gosh, okay, so he had the logbooks of the sea from his grandfather and his great-grandfather and great-great-grandfathers. Huh. Were sailor men. I did not know that. Okay, so he had a long line of sea-related people. But he may have had their logbooks. That's interesting. So I wonder if they're in this archive somewhere, or whether they were lost. The Greeks and pillars of Hercules. To the Greeks, the pillars of Hercules were the end of the world indeed. There the sun sank into his ocean bed, and nothing but the sea of darkness lay beyond. In other words, the Phoenicians kept their secret and drew a curtain over the wide field of their adventures in navigation and commerce, because the Phoenicians went all over the Mediterranean. What is that? That is a picture of Europe and the US. But what does that have to do with anything? It seems to be... What on earth is this? Height? What is he trying to work out here? Well, let's see. The Wyville-Thompson Ridge. Spring of 1905. Depth in meters. Okay, so that must be an ocean ridge. I wonder if the Wyville-Thompson Ridge is to be found in modern times. Let's see. Oh, it is. Wowee. There is an undersea feature called the Wyville-Thompson Ridge. Let's find out where it is. Since I have no idea where it is, let's do a georange of the whole Earth, where it's just going to show us some random piece of the... Oh, okay. It seems to be in Scotland. So let's just make okay, I'm curious where this is. So geolist plot of that with georange arrow Scotland. Interesting. Okay, that's cool. So that is now so I wonder how that was measured, because if they know the depth, the temperatures, they must have put a thermometer on the end of a line to measure that. Well, that's interesting and curious. At least we know where it is. Okay, let's put our picture there. On a specimen of Siriuthus milleri, a specimen of this interesting cephalopod was obtained by our fishery cruiser in 1907. Okay. Mulleri. Siriuthus mulleri. Okay, let's see whether we're going to get a picture of the creature. Cephalopod. Okay. I know it's the same thing. Wait a minute. The rarity of the creature, the delicacy of its semi-transparent and almost gelatinous body. Okay. The length. What does this creature look like? That looks like it's the inside of the creature. Oh, there he is. A swank creature, to be sure. Wow, okay. That's a pretty weird looking creature. Reviews an obituary and an article on Theophrastus. Okay. Theophrastus was a big one for an early plant work on plants. Blah 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 blah. Theophrastus. Okay, so we've moved into a different subject here, I think. Died there suddenly at the so and so. So these are obituaries. Okay, so those are they always make interesting reading because they tell one, what's this? The Fishery Board for Scotland. Oh wow. Oh, that's fun. I see. So that's the net used. So this is the actual, this must be data on the catches that were found. A bunch of fish I've never heard of. The plaice and the lemon sole. Plaice, you always used to be able to get that at restaurants in England. I haven't seen it much in the US. It's a very fine flat fish. But these things here, I've never heard of those. Oh, I see. Hauls, that's the number of the haul. And then this is counting the number of fish found in each haul. I wonder if they still do that. Okay. And now we're back to Theophrastus. And now, Monsieur le Professeur D'arcy Wentworth Thompson in 1926. From Gustav Sen, I see, of Basel. That was the person who he just wrote the obituary of there. Oak galls. Following study of oak galls. Okay. Great. Memorandum for examiners with regard to bursary competition adjustment of marks. Oh wow, this is a grading curve. Huh. That's interesting. Let's see what he did with grading curves. Wow, that's interesting. I wonder the quartiles, etc., 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 etc. This is, wow. Well, I guess there's nothing new under the sun here. Set one subject as nearly as possible with the other one. Okay. Two comparisons. Blah 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 blah. Yeah. Okay. So, oh, there we go. There's a grading curve of some kind. Okay, that's interesting. Marks a higher. I don't quite understand. So this, I see. So that's the 100%, and then there are various different corrections that should be applied. Diagram to illustrate the current practice of scaling. I see. Okay. You know, that graph paper looks exactly like the kind of graph paper that I used to use in the late 1970s. 1939. Latin unscaled, French unscaled, 1922, 1925. Well, they definitely were looking at over the long term there. I guess these, unlike more modern times, what is this? Hypothetical distribution of marks. Oh, that's interesting. That's interesting. Those are like bell curves. That's like IQ test curves and things. Huh. Similar diagram. Foreign languages. Well, that's definitely not a very convincing. Neither of those are actually very convincing bell curves. Alright, what's this thing here? Those are specific marks, I would assume, which are being analyzed. And that seems to be some kind of place where he's recording on what page or something particular words occurred in. Greek words. Boutamos. Who knows? And they have the left-hand side absolutely. Oh. This is yeah, okay, so these are comments on the translation of Aristotle's Natural History, and which is one of D'arcy Thompson's early works. Yeah, okay, so there's a bunch of Greek there. Okay. References to Aristotle. Am I at the end? Wow, I got to the end. All right. Well, I don't know if anybody. This was fun for me, at least, and I'm glad I managed to get through all of those documents. So there's a bit of homework to do here, trying to figure out whether we can reproduce the tide tables and things. Yeah, interesting. Okay. All right. Well, that was something different. People should let me know if they thought this was interesting, because I do these history projects from time to time, and usually I just do them quietly on my own. Yeah. Thanks. Well, at least somebody is saying thanks. That's great. All right. Well, good night, everybody. I'm going to stop here. Thanks and bye.